Welcome to my channel Phi Concepts CHM. This is the fifth part of the series of Introduction to Optical Fiber, where we will study about the classification of optical fibers. We will see about the single mode step index fiber, multi-mode step index fiber, and graded index fiber. Classification of optical fibers. We can classify the optical fibers on the basis of the refractive index profile, on the basis of mode of light propagation, and on the basis of materials. First we will see on the basis of refractive index profile, we can classify it into step index fiber and the graded index fiber. On the basis of mode of light propagation, we can classify it into step index single mode fiber. Next is step index multi-mode fiber, and third is the graded index multi-mode fiber. On the basis of materials, we can classify it into glass, that is glass core and glass cladding. Next is plastic, and third is plastic clad silica. First we will see about the single mode step index fiber. This is a single mode step index fiber. It has a very thin core. This is the core. The diameter is between 8 and 12 micrometers. The core has a uniform refractive index, which we denote as N1. It is usually made of germanium doped silicon. The core is now surrounded by the cladding, a thick cladding of lower refractive index. We will denote the refractive index of the cladding as N2. The cladding diameter is of the order of 125 micrometer. Again, the cladding also has a uniform refractive index, which is shown here in this refractive index profile. So the N1 is the refractive index of the core, which is remaining uniform throughout the core, and the same thing goes for the cladding. The refractive index remain the same as N2. So the refractive index of the fiber, you can see from this diagram that it changes abruptly at the core cladding interface. So hence it is called as a step index. So we can write down N of R. R is the radius of the, we can say radius or the distance inside the fiber, and A is the radius of the core. So when the distance is less than A, it is less than the radius of the core. For the core, that is we are considering the core, for that the refractive index is given as N1, and for a distance which is greater than the radius of the core, that is outside the core, we are talking about the cladding, there the refractive index is N2. We will study about the propagation of the light in a single mode fiber. The light here is traveling along a single path along the axis, hence we call it as a single mode. There is only one ray is traveling. You can see in the diagram that one ray is traveling along the axis. Numerical aperture and the fractional refractive index are very small here. We can, this relatively small value can be achieved by reducing the fiber radius and by making the delta, that is the fractional refractive index, to be very small. So low numerical aperture, that means the acceptance angle is also low, and hence the coupling of the light into the fiber becomes difficult. That is, the launching of the light into the fiber is difficult. So we are just launching only one ray into this. It is very thin, the core is very thin, and one ray of light is traveling through the core. So that means we require a very highly coherent beam. So hence we use laser diodes. So laser diodes, they are very costly. So they are needed to incident light into the optical fiber. Next is the multimode step index fiber. So it is quite similar to the single mode step fiber, except that here the core is of larger diameter. It is about 50 to 100 micrometer. The cladding diameter is between 150 to 250 micrometer. So again, it is the same like the step index only. We can see that refractive index profile, it is looks like a step index only. Only thing is that the diameter of the core is large compared to the single mode step fiber. Propagation of light in this kind of fiber, it allows finite number of guided modes. That is, guided modes means multiple paths of light rays can be passed or can be launched into the core. So you can find many zigzag paths of propagation inside the core. The path length along the axis of the fiber is shorter, while the other zigzag paths are longer. You can see if the ray of light which is going along the axis, it will reach earlier compared to the other rays of light which are going in a zigzag manner, because they are suffering total internal reflection at the core cladding interface. Hence, the lower order modes, they reach the end of the fiber earlier. That is, the rays which are moving along the axis of the fiber. And the higher modes, that is these paths which are shown in a zigzag manner, they reach after some time delay. Next is the graded index fiber, which in short can be called as GRIN, G-R-I-N. It is a multi-mode fiber. That is, many modes, multiple modes of light. Many light rays can be launched into this kind of fiber. So here the core consists of concentric layers of different refractive indices. We can see the refractive index profile. Here the refractive index of the core, we can see it is varying. It is like increasing, becoming maximum at the center, and then it is decreasing. So the refractive index of the core it varies with the distance from the fiber axis. It has high value at the center, and it falls off with increasing radial distance from the axis. So because of that, there will be a periodic focusing of light propagating through the fiber. The size of the fiber is about the same as the step index fiber. So we can write down the variation of the refractive index of core with the radius measured from the center as n of r is equal to n1 into square root of 1 minus 2 delta into r upon a raised to alpha. This is when the distance is less than the radius of the core. So that is, we are talking about the region inside the core, and outside the core, that is in the cladding. When r is greater than a, the refractive index will be n2. So that refractive index of the cladding remains uniform. Alpha is the grading profile index, which varies from 1 to infinity. The acceptance angle and the numerical aperture decreases with radial distance from the axis. This is the formula for the numerical aperture. We'll see the propagation of light in this kind of fiber. So the light ray, as the light ray goes from a region of higher refractive index to a region of lower refractive index. So like when you talk about this ray, it is going from the center, moving away from the center, and it then strikes the interface of the core and cladding. So that time it is going from the higher refractive index to a lower refractive index, and when it strikes the interface of the core cladding, here it suffers total internal reflection. So it is bent away from the normal. Okay, the process will continue till the condition for total internal reflection is met, and then the ray travels back towards the core axis. So from here again it will travel back towards the core axis. Again it will suffer refraction. So this refraction or the turning around may take place even before reaching the core cladding interface. So after total internal reflection, it will be followed by refraction, and then again total internal reflection, again refraction, again total internal reflection, then again it will suffer refraction. So this will be occurring continuously. The rays making larger angles with the axis, they will traverse a longer path, but they will travel in a region of lower refractive index, and hence at a higher speed of propagation. Consequently, all the rays traveling through the fiber, irrespective of their modes of travel, will have almost the same optical path length and reach the output end of the fiber at the same time. So we'll just summarize whatever we had seen now. First, we had seen about the single mode step index fiber, where the diameter of the core was very small. Then we saw the multi-mode step index fiber, where many modes of light rays can be launched into the fiber. And the last one was the graded index fiber, where the refractive index is not like a step as we had seen in the single mode and the multi-mode. Here the refractive index is varying. Thank you for watching this video.